Hello everyone, and welcome back to today's lesson. Today, I will explore the fundamental concepts of the distributions of data, which is a skewness of data distributions. So data analysis often involves examining the distributions of data pointers, and one crucial aspect to consider is the skewness. The skewed distributions provide essential insights into the asymmetry of data pointers, revealing patterns that might not be apparent at first glance. Understanding the characteristics of positively and negatively skewed distributions is fundamental for interpreting data accurately and making informed decisions. In this tutorial, I will delve into the concepts of skewed distributions, exploring both positive and negative skewness with real-world examples and corresponding visualizations. By the end of this tutorial, you will have a comprehensive understanding of how to identify, interpret, and analyze the skewed data, empowering you to navigate complex data sets with confidence. Please like, share, and subscribe, and write your comments in the comment section of this video. Let's go. What is skewed distributions? The skewed distributions in statistics refers to the lack of symmetry in a probability distribution. It indicates that the data point is not evenly distributed around the mean, which means the data point is not evenly distributed around the central tendency of your data set, resulting in a longer tail on one side of the distribution than on the other. So one side, the data can be distributed in one side, and the other side is the skewness. So basically, there are two types of skewness in statistics. So there are two main types of skewness. The first one is positive skewness. Positive skewness is also known as right-skewed distribution. It occurs when the tail on the right side of the distribution is longer or fatter than the left side. On the other hand, the mean is typically greater than the median. That is called a positive skewness. So here I will show you step by step how you can visualize the skewness of your data set. Here I will show you just using a right-skewed data set, but you can implement these steps in your real-world implementation of machine learning using your own data set. So here first import NumPy NLP, import matplotlib, and now generating the right-skewed data set, data pointers. But in your application, you have to use your own data. But here I will just show you how the data is distributed or skews in the right-skewed distribution by generating right-skewed data points. Okay, data, and I can use random data. There is two. I'm gonna create 1,000 data pointers. Now find the mean and median, because that's very important to compare the mean and the median, because by comparing the mean and the median, we can understand the data is right-skewed or left-skewed. Okay, so find the mean and median of the data pointers. the mean, we can use mean if our positive skewed. And median is only because okay. Now I can understand the means and medians of the data points and going to visualize the distributions of the data points with mean and median to understand the data is skewed to right or left. Okay. And the histograph. Histograph is one of the most powerful visualization tools that used to visualize the distributions of the data points. That is very essential. Then I can pass the data I have generated data, and the beans that is very essential parameter that pass to the hist function that used to divide the data points into 30 beans or intervals. And the color, we can identify colors to sky blue and edge color deep blue. Now, alpha is 0.7. Okay. Now I can plot the mean and medians as well to easily understand where is the mean, where is the central tendency, where is the medians of the data points, the mean and median of the data points. Here will be x, v, line, and I can pass mean instead of that color. You can put different colors and line style. Yeah, that is good. And line weights, you can put the line weights to 1.5, and level, can put level, mean, where. Okay, you can copy this and you can change the mean to median to plot the median as well. Color to blue, change blue, and convert this to median. Okay, that's good. And we are going to specify the title. Positive skewness, which is right-skewed distribution. And we can specify the font size, is 50, and so on. And fidelity X label, you can specify the label of value font size is all by label, which is the frequency. All right, finally, fidelity legend that show us the legends of the mean and medians of the data points. And finally, put fidelity dot show. Okay, let's run this code and let's see the distributions of our plot. Okay, there is error. Okay, this is what it is. Yeah. Okay, this is the positive skewness, right-skewed distribution. As you can see, the mean and median. The mean is the red dashed line, and the median is the blue line. So vertical lines that represent the mean and median, and the data is distributed as positive skewness, which is right-skewed distribution, which means when the tile on the right side of the distribution is longer, you can see that the tile of the right side of the distribution of the data point is longer, and the left side up. You can the left means after the mean and median of that. So when you compare, the mean is here, for example. So the right side of the mean is longer tile, which means the data point, the values of the data point is less, and it has a longer tail than the left side of the distribution. And the other comparison to understand that this is a positive skewness or right-skewed distribution is that the mean is typically greater than the median. Yes, here the mean is 2.05 and the median is 1.42. So according to that, the mean is greater than to the median. So this means that it is a positive skewness, so right-skewed distribution. So we can understand. So in the real world, you can implement this positive skewness of your data set, or you can plot the skewness of or the distribution of the data set, and you can understand either the data point is skewed to the right or left of the mean and medians of the data points. So you can easily understand by following this step-by-step implementation, and you could understand the data pointers, which is either skewed to left or right. So you can implement the same strategy to understand the data point is skewed to negative, which means left-skewed distribution. The negative skewness, also known as left-skewed distribution, it occurs when the tail on the left side of the distribution is longer or fatter than the right side. It is the opposite of positive skewness or right skewness, because in the positive skewness, the tail of the right side of the data point is longer than that of the left side, because we divide the data point into two according to the mean of the data pointers, and we can understand the data in which side the data point is distributed. Okay. Now I can implement the same strategy, but here you can put negative in the data points of here, and you can change to negative skew. That's it. And you can run this code and you can understand the data point is skewed to left or right. So according to this, the data point is skewed to left. So according to the negative skewness, that it occurs when the tail on the left side is longer or hotter than the right side. So the mean is this one. The red side line represents the mean, and the blue line represents the median of the data point. So this is not a positive skewness, a negative skewness. Negative skewness, which is, sorry, left skewed, which means the tail on the left side is longer than the tail on the right side. So this is long tail after the mean of the data pointers in the right side and the left side. So and in this case, the mean is typically less than the median. You see, the mean is -2 and the median is -1.3. So we can compare that the median is higher than the mean, which means the mean is lower than the median in the negative skewness. Okay, in the negative skewness. So, but in the positive skewness, the mean is greater than the median. Here, the mean is less than the median, which means the data point is skewed to the left side of the distribution, which means the tail of the left side is longer from the center of the data points than the right sides of the distribution of the data points from the center of the data points, because here is the center of the data points at 2. So when you look at this distribution, on the left side, it is longer than on the right side of the distribution. So this is called left-skewed distribution. So this is also not if the data point in the real world applications, if your data point has a negative skewness or positive skewness, so that is not a good sign because it may have outliers or improper implementation of machine learning. So it has negative indications in your machine learning model performance. So once you understand how you can identify the skewness of your data pointers, you can take a measure to solve the skewness of the data pointers. Okay, here are the application of the skewness. The skewness can be used in a variety of ways, including identifying outliers. When do you use a skewness of your data point? One is identifying outliers. If your data points have outliers, for example, some data points are very far from the center of the data point. So, for example, in this case, on the right side, the data point is very close, but in the left side, the data point is very far from the center of the data point. So it has outliers. So you have to take care while implementing machine learning. Outliers to not a good for the performance of your machine learning model. Okay. And the other is assessment risk. And the assessment risk skewness can be used to assess risks in financial markets, especially. For example, a stock with a positively skewed distribution is considered to be a risk than a stock with a normally distributed return. Yeah, if the financial or the stock of a financial market has a positive skewness, which means it can be considered as a secure or riskier than a stock with a normally distributed return. Okay, and the other is improving machine learning models, because skewness can be used to improve the performance of machine learning models. I've said For example, a machine learning model that is trained on the skewed data may not perform well on new data. If your data point has a skewness, either positive or negative skewness, the the data point will not perform well on the unseen data that is not skewed. By transforming the data to reduce skewness, you can improve the performance of the machine learning model. So overall, the skewness is a valuable tool for understanding and describing data distributions. It can be used in a variety of applications, including identifying outliers, assessing risk, improving machine learning models. Being able to recognize and interpret skewed data enables researchers, data analysts, and decision makers to drive meaningful insights and make informed decisions. By understanding the implication of skewness, you can unlock a deeper understanding of data distributions, leading to more accurate analysis and informed decision-making in your respective fields. I hope this tutorial was helpful. Please like, share, subscribe, and write comments in the comment section of this video tutorial. Thanks for watching. I will see you in the next video.